Hello everyone, welcome to lecture series on the topic point estimation. Under point estimation we know statistic, a function of sample observations is called statistic. It is denoted by Tn of x is equal to T of x1, x2, xn. For example, sample mean x bar and sample variance s square. Here estimator means the statistic which is used to estimate the unknown parameter, and estimate means a specific value of an estimator is called an estimate. For example, while estimating the average height of students in a college, the sample mean x bar is an estimator and the exact value of sample mean, say x bar is equal to 160.8. Here it is the correct value for the estimated value. It is a estimate. Let Tn of x be a statistic which is used to estimate the unknown parameter theta or a function of parameters, say g of theta. If the value of Tn of x are real numbers, then Tn of x are called point estimators. The process of obtaining point estimators is called point estimation. Point estimation admits two kinds of problems, namely one is to obtain an estimator to estimate the unknown parameter, and second one is to suggest the methods or techniques to select an appropriate or best estimator among the unlimited number of estimators exist. So, it is clear that for estimating a population parameter, there may exist a number of estimator, but our problem is to find out a good estimator. So, according to R.A. Fisher, estimator is said to be good estimator if it satisfies the following four conditions. It is already discussed unbiasedness and consistency and efficiency, sufficiency. Here we are going to discuss about the efficiency of the good estimators. Here efficiency is among two unbiased estimators Tn and Tn star for parameter theta. Tn is said to be more efficient than Tn star, that is same as if variance of Tn is less than variance of Tn star. That is, an estimator with the variance is said to be more efficient and consequently more reliable. Suppose variance of Tn star is less than variance of Tn, then the relative efficiency of Tn with respect to Tn star is given by expectation of Tn is equal to variance of Tn star divided by variance of Tn, which is less than 1. However, this ratio is equal to 1, then Tn and Tn star are to be equal efficient. A random sample of size 2 is drawn from the population with the mean mu and variance sigma square. Here we consider one of the example, which is a random sample of size 2 which is drawn from the two populations with the mean mu and variance sigma square. Define under the statistics T1 is equal to x1 plus x2 divided by 2 and T2 is equal to 2x1 plus 3x2 divided by 5. Here we are going to consider whether these two statistic estimators are unbiased and which of the two is more efficient. Consider the first one. First we prove that whether it is unbiased estimator. Consider expectation of T1 is equal to, here T1 value is x1 plus x2 by 2, applied here expectation of x1 plus x2 by 2 is equal to 1 by 2 into expectation of x1 plus expectation of x2. Here we know that for the population mean is equal to mu, then we apply 1 by 2 into mu plus mu is equal to 1 by 2 into 2 mu, 2 get cancelled. Therefore, expectation of T1 is equal to mu. Hence, we can conclude that T1 is an unbiased estimator of population mean mu. Similarly, we consider expectation of x1, expectation of T2, that is equal to expectation of 2x1 plus 3x2 divided by 5. Here T2 is 2x1 plus 3x2 divided by 5. So, we apply the value of T2, that is equal to 1 by 5 into expectation of 2x1 plus expectation of 3x2, that is equal to 1 by 5 is equal to expectation of 2x1 plus expectation of 3x2. Here it is 2 into expectation of x1 plus 3 into expectation of x2. Expectation of x1 is equal to mu and expectation of x2 equal to mu, then 5 mu by 5 is equal to mu. Therefore, T2 is an unbiased estimator of mu. Next, consider the variance of T1, that is equal to variance of x1 plus x2 divided by 2 is equal to 1 by 4 into variance of any constant. It is comes out of the variance, it takes the square of the value. So, 1 by 4 into variance of x1 plus variance of x2, that is equal to 1 by 4 into 2 sigma square, that is equal to 0.5 sigma square. Similarly, consider variance of T2, that is equal to variance of 1 by 25 into variance of 2x1 plus variance of 3x2. It gives variance of 1 by 25 into 4 sigma square plus 9 sigma square, that is equal to 0.52 sigma square. Therefore, variance of T1 is less than variance of T2. Therefore, T1 is more efficient estimator. Go through the second problem. If x1, x2, x3 are 3 independent observations drawn from population with the mean mu and variance sigma square, find the relative efficiency of T1 with respect to T2 and which is more efficient when T1 is equal to 3x1 plus 2x2 minus 4x3 and T2 is equal to 3x1 minus 5x2 plus 3x3. And third question is whether T1 and T2 are unbiased for mu. This question is given to you students. Please solve the question and get the answer. Thank you.